Okay, on question 3, it wants us to use these unbalanced equations and figure out what our limiting reactant is. And we're going to assume, got to turn on my pen here, that we have 10 grams of each of these original reagents, the reactants. All right, very first thing I'm going to do though is balance the equation. I have these two oxygens here, so I'm going to back up here and put a 2 in front of that, and I'll put a 2 there. And silicon's fine, so that is balanced. All right, the next thing I'm going to need to do this math is get the molecular weights, and I'm just going to put them underneath these our reactants. So I have just a single silicon. Silicon's atomic molecular weight is 28.09 grams, and then CO, carbon is 12.01, and oxygen is 16. So molecular weight of carbon monoxide is 28.01 grams. All right. I have everything I need to actually figure this out now. So I have the balanced equation now, and I have the molecular weights of my two reactants. Now, all we're going to do, we're going to do one calculation. We're going to actually see if the silicon is enough. So we're going to start with the 10 grams of silicon that it describes, and then we will convert that into moles using the molecular weight of silicon. And then we have our conversion factor from the balanced chemical reaction of 1 silicon gives us 2 carbon monoxides. And the last thing we're going to do is use the molecular weight of carbon monoxide to figure out how much carbon monoxide we would actually need. Alright, so 10 divided by 28.09 times 2 times 28.01. So to use up all 10 grams of silicon, silicon, we would need 19.9 grams of carbon monoxide. Well, the problem says we have 10 of each. We only have 10 of the carbon monoxide, so carbon monoxide is limiting in this problem. Alright, on the next one, going to do the same type of thing. So we're going to get the molecular weights of the sodium carbonate and the acetic acid first. So sodium has a molecular weight of 22.99. Carbon, oh, there's 2 of those, has a molecular weight of 12.01. And oxygen has a molecular weight of 16. So sodium carbonate is 105.99. Excuse me. Alright, going to do the same thing with the acetic acid. I have 4 hydrogens, that one and those 3. I have 2 carbons. And I have 2 oxygens. So 4 times 1.008 plus 2 times 12.01 plus 2 times 16. The molecular weight of acetic acid is 60.05. Alright, we're going to do something just like we did up here. We're going to assume we had 10 grams of the sodium carbonate. It's 10 grams. So convert that into moles of the sodium carbonate. Oh, I didn't balance the reaction though, did I? Alright, so got 2 sodiums. I would need 2 sodium acetates. That would give me 2 acetates. I need to back up here and give 2 acetic acids. And now the CO3 and those 2 H's would actually give us the CO3 or CO2 in water. So it is now balanced. 1 sodium carbonate needs 2 acetic acids. And then the molecular weight of acetic acid is 60.05 grams. Alright, so how much acetic acid do we use to use up all 10 grams of sodium carbonate? I see that that would be 11.33 grams. That is more than 10, so our 10 is limiting. So the the 10 is limiting of the acetate because we would need 11.3 grams to use up all 10 grams of the sodium carbonate. So our limiting reactant is the vinegar. Alright, got one more of these. I can't move this page up without changing that icon. Alright, so Na2B4O7 and H3PO4. First thing we're going to do, just like the previous one, we're going to get the molecular weight of those two. So 2 of these at 22.99 grams. 4 borons. Boron has a molecular weight of 10.81. And oxygen, 7 of those, molecular weight of 16. Alright, so 2 times 22.99 plus 4 times 10.81 plus 7 times 16 is 201.22. And then the H3PO4, let's see, phosphorus has a molecular weight of 30.97 and oxygen 16. So 4 times 16 plus 3 times 1.008 plus 30.97 is 98.00. Alright, doing the same thing we did up here, so I'm going to take 10 grams of my first species. And molecular weight of it is 201.22. But this next step, I need to get that from the balanced equation. So again, I need to balance this. So I have 2 sodiums in here, and on this side I'm going to have 3. I'm going to start by swapping those numbers, give myself 6 sodiums altogether. Alright, that balances out my sodiums. That gives me 12 borons. So I'm going to come over here and put 12 in front of the H3BO3 because that's where all the boron goes. I'm going to leave the oxygens off because they're all over the place. I want to see what the hydrogens look like now. Actually, how about the phosphates? There's 1 phosphate, there's 1 phosphate. Alright, so if I go from this point, right now I just have 3 hydrogens and 21 oxygens I need to take care of. I have 12 times 3 oxygens, so 30. Wow, I gave myself a complex one here. So 12 times 3, 36 oxygens. What did I say, 21? I'm not going to count these phosphates because I kind of took care of them by putting a 2 there. So I'm counting the phosphates as whole. So, what do I say? 36 minus 21 means I need 15 waters. Let's see, that gives me these 30 hydrogens and 6 more. So 36 and 12 times 3 is 36. That's way more challenging to balance than I'll probably give you on your test. So kudos to you if you balance that one on your own. That's a great, maybe consider that one extra credit. And our last thing is convert that back into grams. Alright, so the 10 grams of Na2B4O7 times 2 divided by 3 times 98.00. To use up all 10 grams, I would only need 3 grams. So 3.46, 3.24 grams of this was H3PO4, and we have 10 grams of it. So our limiting reagent is that original 10 grams. The Na2B4O7 is limiting. Alright, so let me scroll down here so we can see all 3 of these from question 3. The trick was the same on all of them. Since we're just trying to figure out which of our 2 reagents was limiting, figure out those molecular weights, and then just do a single calculation with one of those as 10. And then see how much of the other one you actually need. Since this one was a larger value than 10, we know that we're going to run out of CO, because we only had 10 grams of CO to begin with. And that's how you do this type of problem.